Prepare all the tools needed before starting. If your phone cannot charge properly, the USB port may be damaged or loose. This is the USB charging port. Now we start to replace a new charging port. We will use a microscope to examine the subboard condition in detail. We start by applying flux to the subboard. Why we use flux? It can clean the metal surfaces and reduces surface tension. This is crucial for small USB pins to prevent solder bridges. Now we turn back and apply again the flux to the subboard. Don't forget to flux the connector pins. This helps the solder wet the new metal instantly for a solid joint. Use a soldering iron to tin the pads. The soldering iron acts as a heat transfer tool. It heats the desoldering wick, which then acts like a sponge to soak up the old, unwanted solder from the pads. Why add fresh solder before removal? By mixing new leaded solder with the old factory solder, we lower the overall melting point. This makes the port come off faster and protects the board from overheating. Factory solder has a high melting point. By mixing in fresh leaded solder, we lower the overall melting temperature. This makes removal easier and protects the board from overheating. Heat the solder using a hot air gun. Hold the USB port with tweezers so it doesn't fall off unexpectedly. And take note, be careful not to apply heat for too long, or you risk damaging the subboard. Apply heat in a clockwise motion. This distributes the heat evenly and prevents damaging specific spots on the board. Be careful with the temperature. If it's too high, you risk melting the plastic inside the new USB port. Stick to around 360 degrees. Gently remove the old USB connector. Apply fresh flux to the contact pads. Clean up any residual solder using desoldering wick and the soldering iron. Think of the desoldering wick as a sponge. When heated, it soaks up the old molten solder from the board, leaving the pads clean and smooth. Even a tiny bump of old solder can cause the new port to float. This leads to cold joints where the pins don't actually touch the pads, causing charging failures later on. To use the wick, place it over the pads and press down with the iron. The heat transfers through the copper braid, melting the solder underneath. Once you see the solder being absorbed, remove the wick and the iron at the same time. Dampen the cotton cloth with PCB cleaner. We can use a lint-free wipe instead of cotton. Wipe away the flux residue with the cloth. Cleaning isn't just for looks. Residual flux can attract dust and hold moisture, which might cause corrosion over time. Cleaning the board also lets us inspect our work. Without the flux residue, we can clearly see if all the joints are shiny and bridge-free. Align and install the new USB connector. Make sure the mounting legs are perfectly aligned with the holes before you push the connector in. Apply some flux. Be generous with the flux here. Make sure it coats the inside of the mounting holes so the solder flows through easily. Secure the port in place with tweezers. Apply heat again with the hot air gun to set the port. Keep the nozzle about 2 to 3 centimeters away from the board. Too close and you'll burn it, too far and the solder won't melt. Hold the hot air gun vertically. If you angle it too much, the airflow might push the component out of alignment or cause solder bridges. After removing the heat, hold still for a few seconds. Let the solder solidify before you release the tweezers. Apply some flux again. Solder the anchor points and pins firmly with solder wire. Precision is key here. We need to align the connector legs directly over the subboard's holes so the solder can flow through and lock it in place. Apply again the flux. Reflow the joints with the soldering iron to ensure they are flat and smooth. Finally, clean off the flux residue using PCB cleaner and a cotton cloth. And there we go, the USB charging port replacement is finished. Thank you for watching.